This video is on integration using residues. In today's video, we are going to find the problem using residue theorem. So in this video, we are going to evaluate integral 3 sine z by z square minus z square by 4 into dz, where c is mod z is equal to pi using residue theorem. So clearly, from the question, integral f of z dz is given. So f of z value is nothing but this is 3 into sine z by z square minus pi square by 4. So first of all, we have to find the poles for the given function. So in order to find the poles, so we have to equate this z square by pi by 4 is equal to 0. So this is of the form a square minus b square is equal to 0. So this is a square minus pi by 2 whole square is equal to 0. Now z a square minus b square is nothing but a plus b into this one is a minus b is equal to 0. So now I am going to equate this one. So if I equate this to 0, z value is equal to minus pi by 2, and this value, if I equate this to 0, this will be pi by 2, which are simple poles. So we got the simple pole as z is equal to minus pi by 2 and z is equal to plus pi by 2. Here the circle is given as, so what is the circle? Mod z is equal to pi. So for mod z is equal to pi, which means that z minus 0 is equal to pi. So we have to draw a circle with center 0 and radius pi. So we have to check whether minus pi by 2 and plus pi by 2 are within, on or outside the circles. So this is a circle with center 0. So this is pi, this is minus pi, this is pi by 2 and this is minus pi by 2. If you observe this one, pi by 2 and minus pi by 2 are on the circles. So here pi by 2 minus 90 and plus 90. So here for a circle which is of 180 degrees radius with center 0. So 90 degrees and minus 90 degrees are on the circles. So we have to find the poles. So we have to find the residues for the corresponding poles minus pi by 2 and plus pi by 2. First of all, we have to find the residue value for z is equal to minus pi by 2. For finding the residue value, as you know that residue value is nothing but residue of f of z at point z is equal to z naught, as these are simple poles. This is limit z tends to z naught. This is z minus z naught into f of z. So here z naught value is minus pi by 2. Therefore, residue of f of z, residue of f of z at point z is equal to minus pi by 2 is nothing but limit z tends to, this is minus pi by 2, minus of minus plus pi by 2 into f of z. So f of z value is nothing but 3 sine z by, so I can write this as a plus b into a minus b, that is z plus pi by 2 into this is z minus pi by 2. If I cancel these two and substitute minus, see here, this is minus pi by 2 in place of z. So this will be minus pi by 2 and this is minus pi by 2. So this value is 3 into minus 1 by this is 2 pi by 2. So this value is 2 pi by 2. After cancelling these two, this will be 3 by pi. Clear? So this is the residue value of f of z at point z is equal to, this is minus pi by 2. For the pole value z is equal to minus pi by 2, the residue value here is, this is 3 pi pi. And for the next pole value, here is plus pi by 2. For plus pi by 2, see, for z is equal to plus pi by 2, the residue value here I am writing as residue of f of z, residue of f of z at point z is equal to pi by 2 is nothing but this is limit z tends to pi by 2. This will be z minus pi by 2 into f of z. So what is our f of z value? F of z value is 3 sine z by, see here, this is z plus pi by 2 into z minus pi by 2. This is z plus pi by 2 into this is z minus pi by 2. If I cancel this and substitute in place of z as pi by 2, that is 3 sine pi by 2 by this value will be pi by 2 plus pi by 2. So this is 3 into 1 plus this value is 2 pi by 2 if I cancel, the value here is again 3 by pi. So here the value here is 3 by pi. This is the residue value of f of z at the pole value z is equal to pi by 2. For z is equal to pi by 2, the value here is 3 by pi. So for minus pi by 2 also 3 by pi, and for plus pi by 2 is also 3 by 5. Therefore, according to our residue theorem, so what does our residue theorem states? According to a residue theorem, so integral f of z dz is nothing but this is 2 pi I into sum of the residues of interior poles, sum of the residues of interior poles. So this will be 2 pi I into this is 3 by pi plus this value is 3 by pi. So total this is 2 by pi times of this is a 6 by pi. So if I cancel this one, so this will be 12I. Therefore, this is the integral. So what is f of z value? So f of z is nothing but 3 sine z by, this is 3 sine z by 3 sine z by, this is z square minus pi square by 4 into dz value is 12 into I. So this is how we have to solve. So this is also so simple. Here integral f of z dz is given, f of z is taken like this. So in order to find the poles, we have to equate the denominator to 0. After equating denominator to 0, so this is of the form a plus b into a minus b. So we got two simple poles as z is equal to minus pi by 2 and plus pi by 2. And here the circle value is given as mod z is equal to pi, that is z minus 0 is equal to pi. So we have to check whether these two are within or on or outside the circles. So here is a circle. So this is pi and this is minus pi, this is pi 90 degrees and this is minus 90 degrees. So both the poles are on the circle. Therefore, we have to find the residues. First pole is minus pi by 2. For the residue value of the function is nothing but 3 by pi, and for the pole plus pi by 2, the residue value is 3 by pi, and according to our residue theorem, this is 2 pi I into the sum of the interior poles, that is a 6 by pi, so which is equal to 12I is the required answer. Thank you so much for watching. I have done all the problems which are very important and useful for your examination. Please practice and pass it on to your friends and subscribe to this channel and stay connected. Thank you so much.